Hi, and welcome to my first YouTube video. In today's video, we're going to be focusing on right-angled trigonometry. Now, this is often referred to as SOH CAH TOA. And our specific focus will be on finding missing sides for this lesson. In the future video, I'm more than happy to look at how to find missing angles. Now, by the end of this video, the hope is everyone that watches this video from start to finish will be able to answer question 1. Most people will be able to answer question 2, which requires rearranging in the final step after you form the equation. And some of you will be able to answer a more complex question in SOH CAH TOA, which requires rearranging and double SOH CAH TOA. Now, there are some key words you need to be aware of throughout the entire video. I may not get round to explaining them, but you do need to understand what these are. I will explain what opposite, adjacent, and hypotenuse are, and we should be aware of what a right angle triangle is. Okay, so let's begin the video. Now, when it comes to right angle triangle and SOH CAH TOA, you need to be aware of 2 things. When you are in the GCSE exam and you do see a right angle triangle, it's going to be down potentially, most likely, to 2 topics, either Pythagoras' theorem or right angle trigonometry, okay, or SOH CAH TOA. If an angle is involved, either you need to find the angle or an angle is given, it is more than likely a question to do with right angle triangle geometry or SOH CAH TOA. So how do you begin these types of questions? Well, let's start from the very bottom, which is labeling the right angle triangle. If you have the angle of interest to be 30 degrees, then you need to be able to label all of the sides in relation to this 30 degrees. So the side directly opposite the 30 degrees, we call the opposite. The side that is next to the 30 degrees, it's called the adjacent. And the side that is always the longest side in a right angle triangle, or the side opposite the right angle triangle, is called the hypotenuse. You should be really confident with this because you won't be able to access the question without this basic level of understanding. Now, let's look at some examples in terms of how to label the sides accurately. So let's start with the first one here. We've got a right angle triangle. Our angle of interest is 60 degrees. And we need to find out what the hypotenuse, opposite, and adjacent are in this specific case here. Now, the hypotenuse in this specific case is x, okay? Because it's the side directly opposite the right angle triangle. The opposite, the side opposite the angle of interest, which is 60 degrees, must be y. And therefore, the side next to 60 degrees, or the adjacent, is z. Feel free to pause and try these 2 questions here. So I'm just going to go over it here. The hypotenuse in this example is x because it's the side opposite the right angle triangle. Our angle of interest this time is theta, and the opposite side to theta is therefore 1. And our adjacent in this example is the side next to theta, and that side is 2. So for the final one, the hypotenuse here, sorry, I forgot to label it. Let's call this one C. So the hypotenuse here would be C. I apologize for that. The side that is opposite is A, and the adjacent is B. Apologies for that mistake here, sorry. But I hope you understand what the point of this exercise is in order to be able to label all of the parts of a right angle triangle. Now, after you're able to label, you need to be able to choose which trigonometric function you need to select for the given question. Before we do this, let's start off with a general definition. So sine, cos, and tan are functions which take an angle. It's always of an angle. So sine of theta, cos of theta, and tan of theta. It's always of the angle. And then this gives us the ratio between a pair of sides in the given right angled triangle. Now, if you take sine, it gives you a different ratio than if you take cosine, and that gives you a different ratio than if you took tan. So let's remind ourselves of the labeling of the shape here. So we've got the opposite, we've got the hypotenuse, and we've got the adjacent here. Now, sine of theta looks at the ratio between the opposite over the hypotenuse. Cosine of theta looks at the ratio between the adjacent over the hypotenuse. And tan of theta looks at the ratio between the opposite over the adjacent. So, how do we know how to remember this? Well, what we normally use is SOH CAH TOA. Okay? Where S is for sine, C is for cosine, and T is for tangent. And these two letters next to it are the ratio that you create. It can also sometimes be written as SOH, like this, SOH CAH TOA. It both means the same thing, where this time, in this case, you take the fraction as how it's read, numerator, denominator, numerator, denominator, numerator, denominator. Moving on to some examples so we can put what we've learned into practice. Now, in this part, I'm going to also form the equation, and I'm going to show the calculator trick I was talking about. And this calculator trick genuinely is a lifesaver. So before we get into the calculator trick, let's begin exploring how we can answer this question. So the first thing we have to do is understand what we're being asked. We need to find x in all three examples to three significant figures. In order to do this, let's start with question 1. Before you start, you need to start labeling. Now, we learned in the previous section that the side next to the angle is called the adjacent. So I'm just going to put adj. And the side opposite the right angle is clearly here, is called the hypotenuse, h. So this one uses A and H, A adjacent and hypotenuse h. So you look at your SOH CAH TOA and look to see on the right-hand side of S, C, and T, which one uses A and H. Well, this one sine uses O and H, tan uses O and A, cosine uses A and H. So you take cosine of the angle. So the angle is 40 degrees. And this is equal to the adjacent over the hypotenuse. So x over 4. Now, at this point, I'm sure most of you are capable of solving this from here. But I just want to show you a way that you can verify your answers very quickly on a calculator as well. So even though most of you can solve this, I want to show you that on a calculator, there is a way to get the answer straight away. Now, at this stage, you can solve any question on a calculator, and you should be confident at doing this. It's a very powerful skill that a lot of GCSE students are not aware of. You can solve any equation, more or less. And it doesn't have to be a basic equation. It can be, for example, if you're doing cosine rule or sine rule and you have a more complex equation, you can use a form and equation function on your calculator in order to solve these. So I know this is a one-step equation and you can just solve it by timesing throughout by 4 very quickly. But when it becomes a little bit more complex, students do get stuck, especially when x is in the denominator. We'll see some examples of this later on. So I think it's always good to verify your answer, especially if you can therefore just work towards it. So we know we need to work towards 3.06. All I need to do is times both sides throughout by 4, and we get 4 cos 30. So if I therefore put in 4 cos 30, sorry, 4 cos 40, sorry, 4 cos 40, we get 3.064. Now, if you do want to be taught how to do the calculator trick and multiple other uses of the calculator, like the quadratic inequalities function, the simultaneous equation function, the quadratic formula, factorizing, all sorts, please do feel free to contact me in the description box below. Okay. So we know our answer to this is 3.06. We get x is equal to 3.06, and that's the 3SF. Now, let's try the next question. Again, we start with labeling. So this is directly opposite the angle of interest, 20. So this is going to be an O. And this is the right angle, clearly. So this is directly opposite the right angle. So this is a H. So which one uses O and H? Well, it's sine. So you take sine of the angle, always of the angle, sine 20. Now, sine looks at the ratio between the opposite and the hypotenuse. So we're going to write x divided by 7. Again, I know you can solve this using one step, but I'm just going to quickly put it into the calculator to show you that you can solve this on your calculator as well. And so you end up getting x is equal to 7 sine 20. And if you plug this in on a calculator, 7 sine 20, you end up getting x is equal to 2.39. And this is the 3SF. Okay, 2.39. So 7 sine 20. Okay. And again, you can verify this using the calculator trick. So here is the answer using the calculator forming equations function. So let's move on to the last one. The last one, we have our angle of interest is 25 degrees. Y is therefore the opposite, and 5 is also the adjacent. So now we need to look at which one of these three uses opposite and adjacent. It's not sine, it's not cosine, it's tan, opposite and adjacent. So again, we take tan of the angle, 25 degrees, is equal to the opposite y over the adjacent, which is 5. And again, this is a nice one-step equation. We get y is equal to 5 tan 25. So 5 tan 25 is y is equal to 2.33 to 3SF. So again, at this point, I would have shown you what equation you'd get had you just put it into the calculator at the tan 25 equals y over 5 step. So here's the result you would have got. And here's just to verify, you do get the exact same answer when you do the solving equations function on the calculator. Now, I know it's a one-step equation, and I know you don't need to do it for this particular step. But the point of this video, with this calculator trick in particular, is to make you aware that when the questions do get more complex, you can still use this function, okay? And it's not just for one-step equations. You can do it for more complex equations, where you have two unknowns on the left-hand side, an unknown on the right-hand side as well, or one that requires brackets. It can answer these questions for you. Okay, so let's move on to this question here. Now, these ones require rearranging. So let's begin the question straight away. So this is the opposite, and this is the hypotenuse. So this is going to require, if I was to bring the SOH CAH TOA back down to help you. So this is going to require sine, because you use opposite and hypotenuse. So sine 60 is equal to 12 over x. Now, this one's a little bit more complex because you need to get x out of the denominator. Okay, so let's find out what the answer is on a calculator and work towards that answer. Okay, so here's the answer to the question. So now you're in the exam, you know you're working towards 13.856 and so on. All you need to do is essentially show that you can get to this answer. And if you don't get there, you know you've made a mistake. So let's look at what you will do at this step here. So we have x in the denominator, we need to get rid of it. So times throughout by x, we get x sine 60 is equal to 12. And we just need to divide through by sine 60, getting x is equal to 12 divided by sine 60. So I know the answer should be 13.9 to 3SF. So let's suppose I was in the tests and I incorrectly put in 12 sine 60. This is not the correct answer because we know the answer is 12 divided by sine 60. But if I put 12 sine 60 and I got this answer, well, I know this is not the correct answer because I know the answer should be 13 point something on a calculator. Therefore, my rearranging is incorrect. So now I will do the correct rearranging, which is this, and you know that your x value is divided by sine of 60, which is your 13.9 to 3SF that you were looking for. Okay, so it's a very important and useful tool to know this trick in order to verify your answers. Let's try the next question. So again, labeling, this is the opposite. And if that's the hypotenuse, this is the adjacent, this is the side next to the angle. So we're going to use O and A. O and A is tan. So tan 30 is equal to 4 over x. And again, I'm going to check the answer on a calculator before I do anything. Again, here is the answer to this equation. I just need to work towards this. So I'm going to times through by x. I'm going to get x tan 30 equals 4. And divide both sides by tan 30 to give me x is equal to 4 over tan 30. So 4 divided by tan 30 gives us the exact same answer that the calculator said to us before. And this is 6.93. 6.93 to 3 significant figures because the 8 rounds are 2 up. Okay, now we know how important it is to be able to check our answers and work towards the answers. And I really hope you do get in contact with me so that I can help you with tutoring, how to use the calculator trick, and multiple other functions on the calculator. So we're going to go back to the first page that we started with, and we're going to see if we're still confident in being able to answer some of these questions here. So I said by the end of the lesson, you should be confident with 1, 2, and 3. Okay, so let's go over some of these answers with our newfound knowledge. With question 1, again, we're going to start with the labeling. This is the opposite. Please do feel free to pause the video and try the question at your own pace. So this is the opposite, and this is the adjacent. So we're going to have opposite and adjacent is tan. It's going to be tan of 30 is equal to the opposite, which is x, over the adjacent, which is 10. So we know that x is equal to 10 tan 30. And to 3 significant figures, this is 10 tan 30. This is 5.77. And that's the 3SF. Again, you would verify this on a calculator before you would move on as well. And it's always good that you have this function now. So next one, again, this is the opposite, and this is the hypotenuse. So the one that uses opposite and hypotenuse is SOH, or sine. So sine of 52. Sine of 52 is equal to the opposite, 6.8, over the hypotenuse, which is x. So this is one where the denominator has our x variable. So at this stage, I'm going to check the calculator. Now, I've used what function I was talking about before in being able to solve equations. And I know I'm working towards 8.629. So if I get an answer that's not that, I know I've made a mistake. So I need to solve this. I'm going to times through by x. So x sine 52 is equal to 6.8. And x is therefore 6.8 divided by sine of 52. Okay. And if I put this on a calculator, I know it's going to be right. 6.8 divided by sine of 52. And this was exactly the same number I got to when I used my calculator to verify beforehand. So x is going to equal 8.63 to 3 significant figures. And the last question here, if you want to pause and try this, please feel free. Okay, so we need to find BD. So this here is x, not of the full length A to B, just from D to B or BD. We need to find that length here. In order to do this, it would probably help if I had a little bit more information in how to answer this question. So what I can do first is find C to B, and with that information, I can use that to find CDB. So what I'm going to do is I'm going to model the triangle as this overall triangle first. So the massive triangle here. I'm going to model this entire triangle where I've got my zigzag going in green. And I'm going to try and find CB. So we can say that if this is, for this question, this is the, I'm going to stay in green actually. So for this question, this is the hypotenuse. And this side is the side that's opposite. So we can say opposite and hypotenuse is sine. So sine of 32 is equal to CB over 47. So CB equals 47 sine 32. Now, it's very important you do not convert into decimals at this point and do not round to 3SF at this point. When they ask for BD to 3SF, they're talking about your final answer. If you round during a question, even if it's the end of a part A and you're beginning part B, you need to take the unrounded exact values. Okay, so if you round during a question, you're losing accuracy because the answer to CB is 47 sine 32. So it's 24.906 and so on. If you rounded this to 24.9, thinking that because it says 3SF, I'm going to round at every single point, you're going to be making a massive mistake because you're losing all of that amount of accuracy in your next step. So keep it as its exact value, 47 sine 32. And now we're going to model this right angle triangle in here separately. So the part in blue is going to be done separately. And this time we have more information, which is where I've written some students should know this. This part here is 47 sine of 32. So you have a right angle triangle in here where the angle of interest is 51 degrees. The side opposite the 51 degrees is 47 sine 32. And our unknown is x. So if I label in relation to this internal triangle here, this internal right angle triangle, this is still the opposite and x is the adjacent. So we need to use opposite and adjacent. So that's tan. So tan of 51 is equal to the opposite, which is 47 sine 32, divided by the adjacent, which is x. So you can pause and I'm going to show you how to do this on a calculator. Now, every time I form an equation, I always recommend my students to at least check it, okay? There are some times where you kind of need to be aware of this function. So for example, if there are two solutions, suppose you have some sort of quadratic equation, and there are two solutions to the quadratic, it may only tell you one of the solutions because it's not going to consider the plus and the minus when you square root. So it's not perfect, but I would say in most cases, you should be using it before you finish rearranging your questions. So in order to do this, we times through by x, so we get x tan 51 is equal to 47 sine 32. And therefore, x is equal to 47 sine 32 divided by tan of 51. And I know the answer is going to be 20.2, but I'm just going to show you had I not used the verification. So let's do 47 sine 32, and that's divided by tan 51. So we end up getting 20.2 to 3 significant figures. Okay, so this x here is 20.2, and then you round at the very end, not at this step. Okay, so this is the question I expect most people who watch the video to be able to do. This is the question all people, this one I expect most people to be able to do. And this is for the very top end of grade 5, which is right angle trig, for some people to be able to do as well. Now, again, if you do want to get in contact with me, if you do enjoy this video and you understand how I'm explaining maths to you, please feel free to message me using my contact details in the description box below. I have multiple hints, not just the forming and solving equations hint. There's quadratic inequalities, there's simultaneous equations, there's factorizing polynomials, there's so much on this calculator that a lot of students just aren't aware of. There's substitution, there's the table function for graphs, and all of this is allowed and students are not maximizing it. Please feel free to get in contact with me and then we can discuss this in more detail. I hope you've enjoyed my first video. I apologize for any mistakes. It is my first one, and hopefully I improve going forward. Okay, thank you. Have a good day.